Hi guys, I'm Stu again. And so today I'm going to give you a little introduction to factoring. Um, in Algebra 2, the next thing we need to talk about is solving quadratic equations. But first, we got to do a review of factoring. Because I know this is a big deal. You're supposed to be good at it, but yeah, maybe we're not. We're not so great at it yet. We need some review. So we're going to take a few days to do that. But this isn't just an introduction on some basics behind what factoring is and some history about that get you set up on the right mindset, which is a big deal for me if you haven't figured that out. It's getting on the right track thinking. So let's back up a little bit. Math learning pattern. Okay. So you see that first grade handwriting there? Well, way back in first grade, which is still the kind of handwriting I have now, but hey, you learned addition and then you went to subtraction, multiplication, then division. Moved on up to squaring and then square root. Okay. And you kind of get the idea. What did we do? It's a reversing kind of thing. It's all this reversal thinking. Okay. And so, and then we have this foiling to get you over here and then back over here for factoring. Okay. And so all of this is a reversal kind of thinking. So let's look at some examples here. So for addition, subtraction, it's 3 plus 5 equals 8. 8 minus 5 equals 3. See, look, right there. And then 3 times 5 is 15. 15 divided by 5 is 3. And so you square and then you square root. You FOIL and then you would reverse that and then you would factor back out. And this is where we're heading to, but trying to get you the idea of how we've always done this. Okay. And so you can add and you can subtract, but when you can move from addition to subtraction fluently, that shows a deeper understanding. That's what this reverse thinking is. So it's not just about the math. Math is a good way to help you learn to reverse your thinking process. And so when you notice a phenomenon around you, you're like, oh, this happened, then that happened, or I have so historically that's happened. So now when I run into this situation, I can kind of infer that this other stuff came into place for it to show up. So things like this don't just show up. Where are the building blocks to get here? And so you can reverse the process, kind of thing. A detective, what are they doing? So, well, why is this evidence here? Well, for this evidence to be here, it has to so you're reversing the events that happened. And so math is one of the things it helps you do is take the process. So it's not addition subtraction. It's if you're moving from addition to subtraction, and then from subtraction to addition. Then you go multiplication to division and division to multiplication. It's only it's the same concept. It's just which direction you're traveling. You're going this direction or this direction, which is very important. Okay. So everybody, you can do foiling, but factoring they freak out about. And I always tell them, if you don't understand foiling, and they go, yes, I do. I'm like, well, if you really understood foiling thoroughly, then factoring wouldn't be so incredibly hard. You only have a surface level of it understanding. You get a deeper level of understanding what's really going on and why it works that way, then you can reverse the concept. And that's what's going on. So important, multiply and then factor kind of thing. So let's get some other thoughts out in here. What is a factor anyway? What is a factor? Well, a factor is two or more terms that multiply to equal another term. And so we're going to look at this. We're going to look at the factors. We're going to look at 6, which is just a straight constant number. And then we're going to look at some factors of a variable. And then we're going to look at factors of variables and a number. And how does all that play together? So what is a factor? It's important. So we're stretching our thoughts, not just as, two things that multiply to give me 6, okay? So what are some ways that we can multiply and get 6? Well, real quick and easy, we could say that is 1 times 6, right? Easy enough. Is there another way? Well, sure there is. Or we could say 2 times 3. That's 6. Is that every way? No, it's not. No, it's not. Okay. There's also -1 times -6. Oh, yeah. Now you're thinking, yeah. So you got to remember these things come into play too, and -2 times -3. So all of those need to be thought of when you're thinking about the factors of 6. So that's just a straight constant number, and there's 4 different ways to make that happen. And so you need to go beyond just the straight positives and be able to look at things in different ways. So let's how we could do this. We could say this is m squared times n, or m times mn, or we could say this is m times n. So all of these are factors because there's a couple of things. It's 2 or more terms that multiply to give you another term. So 2 terms, 3 terms, and those are 3. And now this is a special kind of factors. This is what? Prime. Okay, and so that's an important thought there. Okay, that's the prime factorization. All right, so let's look at this guy over here. Pull this guy up here to get him out of the way. All right, we got these 2 terms here. So I'm going to take the first idea here, times. We're just going to go to the primes here. Use 2 different colors this time. And so now I'm going to choose 2 times 3 for the 6 times m times n, 2, 3, 4. Okay. Now, something I want to make sure we observe. This is all multiplication. Now, if this had been a 6 plus mn to the 4th, what we're about to do would be completely illegal. Okay? So it's important to keep that in mind. And so as we get further into this, sometimes we're going to have all multiplication, sometimes we're going to have addition in there, binomials. So don't mix up your rules. Multiplication is not addition. Addition is not multiplication. In this certain, when it comes to this kind of factoring. All right, so something we normally do mentally, I'm going to do actually physically on the paper. I'm going to rearrange this using the commutative property of multiplication since it's all multiplication. So here we go, 2 times 3. Okay, so that's all my numbers. Now let's knock out the m's. Okay, here's a couple of m's over here. Is there any m's over there? Yeah, there's an m over there. So I'm going to make that one green so we can kind of see where they're coming from. So is that all the m's? That's all the m's. Okay, now n, here's an n over here. There's one n there. And then we got these 4 n's over here. So 1, 2, 3, 4. Put our multiplication symbols there. And so this is what you kind of need to be able to do mentally. And that's an important skill to be able to mentally reorder things. But whereas when you first started this, they probably did ask you to reorder everything like this and put it together to help you see what's going on. To be able to zoom in and focus on something and then also be able to see the big picture. Zoom in and focus on just one little thing and then also look at the big picture. And to be able, the more you can do that mentally and not have to write it is great. But the more you do mentally, the more likely you get things all goofied up. So you got to be strategic about when you do which one. And if you find yourself screwing things up too much mentally, you should write more stuff down. Just, hey, just say it until you get better at it. And so what's this simplify down to? This is going to be a 6 m to the 3rd, n to the 5th. Okay? So just reviewing some of those things. But what if, okay, what about something like this? What if you had, let's say, 2m squared n to the 3rd power? What does that mean? What does that mean? It means 2 m squared n times 2m squared n times 2m squared n. So 2 times 2 times 2. Okay, that's going to give me 2 times 2 is 4. 2 times 4 is 8. There's 2, 3, 4, 5, 6. Is that 6 m's if I wrote them all out? And then n to the third power. Now up here, we just added the exponents to get m to the third. But here, if I take 2, on the original problem, 2 plus 3 would be 5, but the real answer is 6. What is different about that? Well, up here, it's just two things being multiplied. This is a power to a power, and people get that mixed up. When do I add my exponents and when do I multiply my exponents? And when you kind of rusty on it, you get those backwards sometimes. And what I tell them is, when in doubt, just expand it out like I did. So I expanded it out, and usually that takes care of the business. Okay, I don't say don't do all of them expanded out, but do one or two to refresh yourself to which ones, when do you add your exponents and when do you multiply your exponents. Okay, because remember, this is a 1, it's into the first power, right? All righty, so there's some review stuff there because you're going to need some of those skills as we get set up into this factoring. Well, I guess I'm going to try to edit that out since it was circling anyway. Nice bell. All right, now guys, 3, 2, 1. Now all that is to set us up to the very building blocks for for algebraic factoring. Okay. Yes, we factored the 6 and the m squared plus times n, and those are factors. But now we're moving into the algebraic factoring that's setting up for our quadratic equations, right? That's the whole point of this. So this is our foundational building blocks. And there's several things. Don't skip over, oh, I'm good at distributive property, I'm going to ignore this. Well, what a lot of times happens is that people are pretty good at distributive property. And when we're doing what we're doing today, they're pretty good at factoring it. But later on, when we start with the factoring part, it can get a little bit more complex and people lose it because they have a surface level, not a deep level of understanding. And so I'm going to try to point out a few things along the way to help keep us refocused on the things that we need to focus on. All right, so let's do a few examples, see how that goes along. So -7 times x plus 4. That's a little small. We'll have to manage that. So what does that mean? Well, a lot of times y'all say, well, that's just -7 times x, and you do like that, right? And that's fine. But I'm going to write it out. What does that really mean? It means -7 times x minus 7 times 4. Okay? And then that gives you -7x minus 28. And so a lot of times we skip out from this middle thing here. Yes, you do it mentally, but you don't write it. And I'm not saying you have to for this particular situation, but I'm saying don't skip over this mental process. Give it the value it deserves. Okay? Because what I find is when I give people this thing on the right and I ask you to reverse it, remember, this is a forward backwards process. Just like addition subtraction is a forward and backwards process. So we are when I give people this end product and I ask them to go back to the beginning, sometimes they get confused because they didn't give this the mental space it deserved, because this is the key for making this happen. Okay, it's a big deal. Okay, now it's called GCF factoring, greatest common factor factoring. However, it is also can be referred to as undistributed property, de-distributed property, reverse distributed property, any kind of prefix you want to put that on there that undoes the distributed property, kind of thing. And it's funny how different prefixes click with different people, but taking it and undoing the distributed property is what that's about. Okay, let me do a few more examples here. Just set you up. Now, I'm going to tell you, though, I am setting you up for some things to come. All right. So see if you can catch on to what I'm setting you up for in a little bit. So that's what distributive property means. X times x times 4. And so that gives me x squared plus 4x. So now I'm going to change to green. So we got 4x, 3x minus 2. And so that means 4x times 3x means everything on the outside times everything on the inside. And we're just going to take it systematically, one thing at a time. Okay. And so that's going to give me 12x squared minus 8x. Let's try one more here. Let's see here. We got x. So that's going to be x times 3x. Okay, so x times 3x. All right, so we got x again, and then times negative 2, which gives us 3x squared minus 2x. Okay, so let's ask you a few questions here. So we did distributed property, and if we did undistributed property, we would get back over here. It's a continuation. It's not two separate things. It's just which direction are we traveling. The vocabulary is important. Okay, so up here, a common factor would be -7, right? For this particular binomial, a common factor would be x. For this binomial, what would the common factor be? 4x, because there's a 4 in both the 12 and the 8. That's the biggest number there. And there's also an x in both of these that we could divide out. Because isn't that what that is? 12 divided by 4 is 3. X squared divided by x is x. 8x divided by 4x. So 8 divided by 4 is 2. And you got the negative because it's negative. X is canceled, so you don't have an x on the inside. And so you're reversing the process. So we're dividing both of those by 4x, and that's what goes inside with the 4x on the outside. So that's kind of some factors of each binomial. Now let's go up here to the blue one. What is a common factor for both binomials? Everything in blue there. Some people say it's an x. Well, the negative 28 doesn't have an x. Well, how about 4? Well, there's not a number in front of the x squared at all, and that's a 7. So there's nothing, right? Au contraire, my friend. Remember we said that a factor is, one of two or more things that are multiplied to give you something else. Our common factor with both of the ones in binomials of blue is x plus 4, okay? Because you got to remember, x plus 4, yes, it's a binomial, but see those parentheses? That also makes it one thing, because it's parentheses, one thing. There's two things inside of it, but it's still one thing. You have to be able to keep that tension at all times. You got to be able to look at x plus 4 in parentheses and think of it as one unit, but also 2 units on the inside. And depends on the situation which one you're going to focus on. So when you're distributing, you're thinking of as x plus 4 as 2 things. When you're trying to factor, you're thinking of x plus 4 as one item. Okay? Because again, how many terms do we have? X is a term, and x plus 4 is a term. So we are factoring. So these two things are factors. Okay? X is not any more of a factor or less of a factor. X plus 4 is not any more or less of a factor. That's what those things are. So when you're asked a factor, you got to keep this, what you're looking for, in your mind. You should always, and with distributive property, please, one thing I always ask people to do, when you actually factor something out, do a quick multiply and see if you got back what you started. Don't take but a second with distributive property. Go, yeah, yeah. Just confirm that you did what you thought you did. Now, check this out. So basically, that's our introductory to factoring, okay, because factoring is just undoing some kind of multiplication, okay? And distributed property, or GC, and then GCF factoring is a building block. It's one of the fundamental things. Much of what we do can come back to this page. And I'm going to try to demonstrate that on our next page here, how that connects. Okay, so add a clean page here. All right, so I'm going to have x minus 7 x plus 4. Okay. Now, many of y'all think of this as FOIL, right? And if you did FOIL, your f would be the what? X times x. That'd be the first term. So that could be x times x for your f of the FOIL. Okay. O of the FOIL is the outside term. So that's x and 4. So you do 4 times x, or x times 4. There's your O. Okay. I is the innards, means the two inner pieces right here will be negative 7 times x. And then L means the last term of both parentheses. And all that is a little device that helps you not forget to multiply something. Because what this means is everything on the left parentheses times everything in the right parentheses. And so we don't want to forget anything. So they came up with this little thing called FOIL to help us remember all the parts, not to forget them. But FOIL doesn't work if you have 3 things, because you only got 4 letters. And so if I have 3 things in my other set of parentheses, I run out of letters. Okay, but FOIL is just a neat way to help you remember those pieces as you're learning how to handle these things. But what you really have been doing is something called distributive property. No, it's FOIL. No, it's distributive property. I promise. Okay. So what you're going to do is let's take its x times everything over here. So I'm going to write it like this: x, open parentheses, x plus 4. Okay. Isn't that what f and o are, right? X times f, that's f. And x times 4, isn't that the o of FOIL? Yes, it is. It's distributive property. Okay, now let's take negative 7. Negative 7. And let's multiply it times x plus 4. Okay, so it's just distributive property twice. That's what this is. And so that's going to give us x times x, x squared, x times 4, that's 4x. Then negative 7 times x is negative 7x. And then negative 28. So there's your F, there's your O, there's your I, there's your L. So FOIL has always been just distributive property. And isn't distributive property easy? Yeah, distributive property is easy. Okay? So distributive property twice, combine your like terms. So here we go. So bring down the x squared, negative 3x minus 28. Okay? So somebody say, whatever, I'm good at FOIL. I ain't paying attention. That's your loss, because what we're going to end up doing is we're going to take things like this and we're going to reverse the process to get back what we started. Just like we learned addition, then subtraction, multiplication, division. It's the same thing, okay? And if I can convince you of that, this will be a lot easier. And it's not so bad, but what happens when you put a number in front of the x squared? Completely throws everything off base. All the little shortcuts get thrown off. And then you have to learn how to do it this way. And that's called algebra 2 instead of algebra 1. Okay? So we're helping you out going with this process. So when you see in your homework, okay, on page 2, okay, on page 2 of this packet, it says FOIL. Let me show you what I mean. I want every single problem to look like I'm going to show you. Okay? I thought that was coming up. So this is how I want to see every single problem done. I want you to write x plus 3 plus 2 times x plus 3. Then that's going to be x squared plus 3x plus 2x plus 6. And see, and I didn't write it small enough, so I'm going to have to come over here to the side, and I'm going to make that x squared plus 5x plus 6. Give it a little circle. Ta-da. So I want those 3 steps on every single problem. No exceptions. Please. Thank you very much. Okay? So while we're here, let's look at the thing. So this page here is very important to get you set up on the right pace, for getting good at factoring. Okay, and to be good at factoring, that means you have to understand FOIL better than most people do. And so I'm setting you up that if you will do this, when we get to the hard stuff, then you will be able to reverse it more easily and they'll make more sense to you. Trust me. Okay, so let me look at a couple more things real quick since this is for homework as well. All right, so on page 1, so we're working through distributed property. So we did this just to make sure you're on track with what's happening here. Okay, we see what's going to happen here is you're going to do this by every one of them. So that's going to be 2 times 9, that's 18, x to the third, y squared, and then you continue finishing that out. Remember, there's a -1 here, so that's -1 times 5, so that's -5. X squared times x squared, that's x to the 4th, and then y squared. Okay, and then you finish that out. The rest of these are just working your puzzles, figuring out what would go in different places with distributed property. Okay. Then the next page is simply doing the FOIL. And then, okay, this is kind of out of order. Your next page is this guy here, practicing the skill of what 2 things add to give you 14, but those same 2 things add to give you 40. Okay, so definitely work on that. And that'd be a good start. That'll be a good start. Now, I don't have in front of us the little diamond worksheet, but you need to do that one as well. Okay, and it's a pretty straightforward kind of deal. I might do a little quick short one when I go find out how that happens. Well, if you'll give me just a second, I'll edit this down and just go ahead and add that in. Okay, here's this little worksheet. It's a little puzzle thing that does very similar to page 3 of the packet. So it's 7 times 4 is 28. 7 plus 4 is 11. 9 times 6, well, that's 54. And then 9 plus 6 is 11. Okay. Then 8 plus what is 14? That's 6, right? And then 8 times 6 is 48. Okay, 6 times what is 42? So that's 7, and then 6 times 7 is 13. Now over here, which I couldn't get to show up, is another little diamond. Well, that's horrible, isn't it? I'm so sorry. You got A and a B. So what's A times B? Well, that's just A, B. What's A plus B? That's A plus B. They're not like terms, so you can't put them together, but they can still be friends. They just got to socially distance by putting a plus between them. Okay? So that's the idea of this worksheet. So page 2, I do want you to work it out just like I showed you, but the rest of it should go pretty quickly. Okay? So if that's good, helpful to you, and let me know if you have any questions.